So the next example, the first thing I have to do is get this into standard form. I'm going to subtract my 9x from both sides. That gives me 9x squared minus 9x plus 2 equals 0. Now I'm in standard form. I'm going to pull out my a value, which is 9, my b value, which is negative 9, my c value, which is a positive 2. And here is my solution. X equals, if my b is negative 9, my opposite of b is a positive 9. Plus or minus, the very first part is to do b squared. 9 squared is going to give me 81. Minus 4 times a times c all over 2 times a, and 2 times 9 is 18. So automatically we cut some steps in this first part right here. I'm going to simplify what is under the radical, and I get x equals 9 plus or minus square root of 81 minus 72 all over 18 . 81 minus 72 is going to give me 9 plus or minus the square root of 9 over 18, which simplifies further. I can break the square root of 9 to be plus or minus 3 over 18. And I am going to split these up into my two fractions. I have 9 plus 3 over 18 and 9 minus 3 over 18. That is 9, 10, 11, 12 over my 18. That has a 6 in common, which is going to reduce down to 2/3. Same thing here, 9 minus 3 is 6 over 18, which reduces to 1/3. Done. You could have factored it, it would have come out to be the same thing. This just works 100% of the time. Moving on, as you can see, I have a very short amount of space here, so this is not going to be a very long problem at all. I cannot do anything to this until I get this over to the left side in standard form. I like to make the executive decision to move all quadratic terms so that this quadratic term is positive, if at all possible. I'm going to subtract 4 from both sides. I get 1x squared plus another x squared gives me 2x squared minus x minus 7 equals 0. I'm going to pull out a, pull out b, and pull out c. And start substituting. I have x equals, again, my b is a -1, so when I take the opposite of -1, I'm going to say +1, plus or minus the square root of b squared. -1 squared is a +1. Again, this value will always be positive because when you square anything, it's going to become positive. Plus or minus 4 times my a times my c all over 2 times a. 2 times 2 gives me 4. this is going to simplify to 1 plus or minus square root of, oops, that is not supposed to be there, 1 minus, and 4 times 2 times negative 7 is negative 56 all over 4. And by now we know that when we are subtracting a negative, that means that we add the inverse. So the 1 plus or minus square root remains the same. That becomes adding the inverse. I get 57 over my 4. And now I have to see if I can break the square root of 57 down. So I said 1 minus my negative 56, so I added my inverse, and that's how I got 57. For 57, that breaks down to 3 times 19, both of which are prime. Nothing is a pair, so there is nothing else I can do with this, which means that is my solution, and it does have both of them. It has 1 plus the square root of 57 over 4 and 1 minus the square root of 57 over 4. So there are both of my answers. So as you can see, I got this down to 1, 2, 3 steps compared to all of that. And the last example, I again have to get this into standard form, so I'm going to add my x squared over. That cancels out. I'm going to subtract my 4x over. That cancels out, and I'm going to subtract my 5 over. 1x squared plus another x squared gives me 2x squared. 6x minus 4x gives me a positive 2x. Minus 5 equals 0. A is 2. B is 2. C is negative 5. This would be a good point to stop the video and try to do this one on your own and see how far you can get into this until you feel like you're getting stuck, and then start watching the video again to try to find where the error is. Okay, so here we go. Hope you had a chance to get to it. I'm going to take the opposite of my b. My b is a positive 2, so my opposite of b is a negative 2, plus or minus the square root of b squared. 2 squared is 4, minus 4 times my a times my c, all over 2 times a, and 2 times my 2 is going to give me 4. I'm going to simplify 4 times 2 times negative 5 next. The negative 2 plus or minus square root stays the same. 4 minus 4 times 2 is 8. 8 times my negative 5 is a negative 40. All over my 2a. Same thing here. I have to add the inverse so I can continue and say negative 2 plus or minus the square root of 40 minus negative 40, which gives me a positive 44. Again, we add the inverse all over 4. And just like we did in example 3, we need to check if I can break down 57. I need to check if I can break down 44. 44 reduces to, or it factors to 4 times 11, and 4 breaks down to a pair of 2's, which means this is going to become negative 2 plus or minus 2 square root of 11 over 4. So this radical could break down. And at this point, I recognize that between this 2, and this 4, there is a 2 in common with all of them. I don't reduce the square root of 11 because I already did. I can't break that down any further. So I'm going to factor out my 2. This is called the Hart method. This is the Hart method. So I can reduce negative 2 over 4, and I can reduce this side. And notice how it created the heart shape. So I can take the 2 out of here, and I get negative 1 in the 2, and then there's a 2 in common over here, plus or minus 1 square root of 11 over 2. And that is my answer. Again, there's the plus or minus, there are my 2 answers involved.